Hello calculus students. In this video we're going to talk about some basic rules for finding derivatives. So the simple power rule is actually a basic rule, but I wanted to cover that by itself in its own video. But here are some other basic rules. The first rule is the constant rule. Let's say that C is any constant. Then the derivative of C is 0. So therefore the derivative of any constant is 0. And that should make sense to you, because if you think about a constant function, it's just a horizontal line. And you should have read somewhere that the derivative represents the slope of the tangent line for a function. And if your function is a horizontal line, then its slope would always be 0. Okay, so if you've got a function f of x equals 5, then the derivative would be f prime of x would simply be 0. Now I do want to just make one comment here. I just get into the habit of always using x as my independent variable, but when you apply these rules can be applied to any variable. You know, the function could be a function of z or a function of t or something else, but I just like to use x because that's generally the most common variable that we use. Okay, now here f of x equals pi. Now pi is a constant, so the derivative of pi would be 0. Okay, now here it doesn't matter if the constant is some weird constant like 2 times square root of 7. The derivative of that constant would still be 0. Okay, so that's the constant rule. Now let's also talk about the constant multiple rule. Basically, the constant multiple rule says if you want to find the derivative of a constant times some function, then that's the same as the constant times the derivative of the function. Or if we want to, we can use a shorter notation. Let's let u represent the function. So the derivative of a constant times u would be the constant times u prime, where u prime would be the derivative of your function. Okay, so right here our function is 7x cubed, right? So what I'm going to do is I'm going to say, well, we know from this rule that the derivative of 7x cubed would be 7, right, times the derivative of this x cubed, and we can apply the power rule to this and get 3x squared. So the derivative would be 7 times 3x squared, which would be 21x squared. So the derivative of that function is just 21x squared. Now the next one, I'm going to have to rewrite it, so I'm going to write 5 times the 4th root of x as 5 times x to the 1/4 power. Now, when I take the derivative of this, since that's a constant multiple, the derivative, I would just bring this 5 down and say, okay, that's going to be 5 times the derivative of x to the 1/4 power. So how do I take the derivative of x to the 1/4? All right, now I did this in my head, so stay with me here. I bring the 1/4 down, so that's 1/4, and then it's x to the 1/4 minus 1. I did that in my head. 1/4 minus 1 gives me negative 3/4. So now I have 5 times 1/4 times x to the negative 3/4. And as I showed you earlier, we can move this to the denominator and write it as x to the positive 3/4. So we get 5 over 4 times x to the positive 3/4. Now the next rules are the sum and difference rule. So these are written, it's really 2 rules, but it's written using one formula here. So if you want the derivative of f of x plus g of x, that's simply the derivative of f of x plus the derivative of g of x. And if you want the derivative of f of x minus g of x, that's the derivative of f of x minus the derivative of g of x. Now you can also use u and v here for the shorthand notation, where we just assume u is f of x and v is g of x. And of course it works the same way. The derivative of u plus or minus v is u prime plus or minus v prime. Looks like I left out the minus there. Stick it in there. So it's u prime plus or minus v prime. Okay, so how do we do this? Well, here we can say, okay, we have square root of x plus 4x to the fifth. First thing I'm going to do is rewrite square root of x as x to the 1/2. And then I have 4x to the fifth. Okay, so let's take, we want to find the derivative of this sum. Now we learned up here the derivative of this sum would just be the derivative of this term plus the derivative of this term. Now this is what I tell students, this is my fixin' to notation. This just tells you I'm fixing to take the derivative of this and I'm fixing to take the derivative of this. Now you could skip this step and go to the next step by doing this in your head, but I'm just trying to show you that I'm going to take the derivative of each term as I move forward. So now the derivative of x to the 1/2 using the power rule would be 1/2 x to the negative 1/2. The derivative of 4x to the fifth, remember how we do that? It would be 4 times the derivative of x to the fifth, and the derivative of x to the fifth would be 5x to the fourth. And then let's clean it up here. We get, we can write the x to the negative 1/2 in the denominator, so we get 1 over 2 x to the 1/2, and then multiply the 4 times 5, and this becomes 20 x to the fourth. So there's your derivative, 1 over 2 x to the 1/2 plus 20 x to the fourth. Now, this works regardless of how many terms you have. So here I have 4 terms in this polynomial. So if I want to find the derivative of this function, I would just take the derivative of each term. So here I'm just showing you that I'm going to take the derivative of the first term, then minus the derivative of the second term, then plus the derivative of the third term, and then minus the derivative of 1. Now, you can probably do these in your head now, but you know that to get the derivative 5x to the fourth, that would be 5 times 4x cubed using the power rule on x to the fourth. So 5 times 4x cubed would give me 20x cubed. And then the derivative of 3x squared would be 3 times the derivative of x squared. So that would be 3 times 2x, which gives me 6x. And this was a minus, so it's minus 6x. And then the derivative of 7x, that's 7 times the derivative of x. And remember, the derivative of x is 1. So 7 times 1 would just give me 7. And then this is a constant, and remember the derivative of a constant is just 0, so I wouldn't add anything for that. And so my final answer would be this derivative here, 20x cubed minus 6x plus 7. Now I'm focusing on mostly just the derivatives, on how to find the derivatives in these videos, these calculus conundrum videos, but I'll go ahead and show you just a couple of applications here. If you're asked to find the slope of a graph, then you want to find the derivative of the graph. So if I'm asking you to find the slope of this function, then you get the derivative. Now I'm going to assume that you can get the derivative. If not, practice this on scratch paper and show that the derivative of this function is 4x minus 3 here. Now, the derivative represents the slope of a graph. So the derivative of this function is really just the slope of this graph of this function. So since the derivative is 4x minus 3, that means that the slope of the graph can be determined at any x value by plugging x into this function. So it says here to find the derivative of this, or the slope of this function, at x equals 3. Well, since the derivative is 4x minus 3, simply plug the x equals 3 in for x into the derivative, and you get 4 times 3 minus 3, which is 9. So now we know that at x equals 3, the original function, this up here, has a slope of 9. Now, the next one, again, this says find the slope of the tangent line of the graph. That's really the same question as finding the slope of the graph, because the tangent line actually represents the slope of the graph. Okay, so again, I give you a function. Go ahead and calculate the derivative for practice on your own and show that the derivative of 2 square root of x minus x is 1 over square root of x minus 1, and then evaluate it at the number given. So it says find the slope of the tangent line of that function at x equals 4. So I will put 4 into the derivative to calculate this. So if you evaluate this at 4, you'll get 1 over square root of 4, which is 1 over 2, minus 1. So 1 over 2 minus 1 is negative 1/2. So we know this function at x equals 4 has a slope of negative 1/2. Now you might also be asked to find the equation of the tangent line. So here, remember we learned earlier that this says find the equation of the tangent line of this function at x equals 1. Okay, well remember, first of all, you want to find the slope of that tangent line. So take the derivative, and remember the derivative is 4x. Scratch that. What I did first here is I found the corresponding y value. So we need the corresponding y value for this, so we'll plug in 1 into this function to get the y value. So if I plug 1 into the function, I get 2 times 1 squared minus 3 times 1 equals negative 1. So the corresponding y value is negative 1. So the point at x equals 1 would be, the x value would be 1 and the y value would be next 1. Now this says the slope was found above as m equals 1. It actually wasn't found above because I did 3 above. But let me just show you real quick, and I'll show you how to find the slope. So the derivative of this function is 4x minus 3. And since we want to know the equation of the tangent line at x equals 1, all we have to do to find the slope of that tangent line is plug 1 into the derivative. So let's plug 1 into this derivative. So if we plug 1 into this, we get 4 times 1 minus 3, which is 1. So that tells me that the slope is 1. Okay, so now I can find the equation of that tangent line because I know the slope is 1 and I know the point is 1, negative 1. So using your point slope form, you can just go y minus negative 1, which would be y plus 1 for the y value, and then the slope times x minus x1, so 1 times x minus the x value. And then the rest of this is just a little bit of algebra. 1 times x minus 1 is just x minus 1. Subtract this 1 from both sides, so you get x minus 1 is x minus 2. So the equation of the tangent line for this function at x equals 1 would be x minus 2. Now I challenge you to graph the function and then graph this tangent line, and you'll see on the graph that this tangent line just barely kisses this function at the point 1, negative 1, and therefore is tangent to it. Alright, this is my last application here. So we have 2 square root of x minus x, and we want the equation of the tangent line at x equals 4. So we plug 4 in here to get the corresponding y value, which is 0. So we have the point 4, 0. Now this one we did find the slope for earlier, as it was negative 1/2. So we know the slope of this graph at 4 is negative 1/2. And then we use the formula y minus y1 equals the slope times x minus x1, and since the y value is 0, we get y minus 0. The slope is negative 1/2, so we get negative 1/2 times x minus the x value, which is x minus 4. And then if you distribute the 1/2, the negative 1/2, you get negative 1/2 x plus 2, because there's no number to move across the equal sign here, so we just get negative 1/2 x plus 2. And again, if you graph this and graph this and look, you'll see that this graph just barely touches this graph at the point 4, 0. Therefore, it's going to be tangent to the function at the point 4, 0. Now, my next video is going to deal with trig functions. So if you're in a business calculus class, you might want to skip the video on simple trig functions. But if you're in a Calculus 1 class, you do need to cover this.